cells and hormones can influence release of other hormones. Your goals for learning are to study hypothalamic pituitary axis anatomy, to review the hypophyseal portal system, to identify the sources of endocrine and neural control of the hypothalamic pituitary axis, to review thyroid hormone. Here's what you need to know. The difference between a neurotransmitter and a hormone, the difference between somatic and autonomic nervous systems, the role of the hypothalamus in control of the autonomic nervous system. To see definitions of terms, click the bold red words. Recall that the pituitary gland, also called the hypophysis, lies beneath the hypothalamus. It is attached to the hypothalamus.
Ядра, и как они связаны? Не спешите пока переключать. Это переднее, как оно называется? Переднее как называется? Аденогипофиз, потом передняя часть нейрогипофиз. И посмотрите, как передняя часть связана большими аксонами, да? Здесь идет выработка гормона, а в задней части гормона нет. Но зато они связаны с этими ядрами, в которых вырабатывается нейросекрет, который, проникая, становится гормоном. Так.
Pituitary gland in humans consists of two lobes. An anterior lobe that is made up of endocrine tissue, and a posterior lobe that is made up of neural tissue. The anterior lobe and a small portion of the infundibulum make up the adenohypophysis, and posterior lobe and most of the infundibulum make up the neurohypophysis. We have reviewed 6 hormones secreted by the anterior lobe of the pituitary. They are thyroid-stimulating hormone, or thyrotropin, follicle-stimulating hormone and luteinizing hormone, the gonadotropins, adrenocorticotropic hormone, or corticotropin, growth hormone, and prolactin. These are considered the classic anterior pituitary hormones because their structures and physiological functions in humans are well understood. 4 of these hormones, TSH, FSH, LH, and ACTH, are called tropic hormones because they cause the release of hormones from other endocrine glands. Drag each tropic hormone over its target tissue.
Влияет на поджелудочную? Нет. Дальше на что еще не влияет? Тиреотропный как же? Тиреотропный, меланоцитостимулирующий есть. Дальше пролактин, лютeinизирующий на всех. Получается, что он только не действует на поджелудочную. Нет специального гормона, который там они по принципу обратной связи регулируют. Так, ну давайте.
The ventral hypothalamic hormones that influence the release of tropic hormones and growth hormone are the first hormones in a series that ultimately regulate the secretion of hormones from target glands. The target glands include the thyroid gland, gonads, adrenal cortex, and liver. It secretes insulin-like growth factor.
Вырабатывается релизинг
A ventral hypothalamic hormone controls secretion of an anterior pituitary hormone that stimulates secretion of a hormone from a target gland. The final hormone in the chain acts on target tissues of the body. This kind of complex control system provides many input sites where other hormones and neurons can act to achieve fine control over the endocrine system. Let's look first at the influence of hormones. For each hormone series, negative feedback loops control circulating levels of the target gland hormone. Negative feedback exerted by the target hormone can be directed at the anterior pituitary, the ventral hypothalamus, or target hormones from one series can also influence the secretion of hypothalamic or anterior pituitary hormones from another hormone series. We have looked at negative feedback control for thyroid hormone and cortisol in topic 2. Let's review them briefly here. Click the pituitary gland to continue. Thyrotropin-releasing hormone acts on cells of the anterior pituitary to increase secretion of thyrotropin, TSH, which in turn acts on the thyroid gland to increase secretion of T3 and T4. The thyroid hormones feed back almost exclusively to the anterior pituitary to inhibit secretion of thyrotropin. T3 and T4 to continue. Thyroid hormone is also essential for anterior pituitary cells to secrete growth hormone. Click GH to continue. Corticotropin-releasing hormone acts on cells of the anterior pituitary to increase secretion of corticotropin, ACTH. Corticotropin acts on the adrenal cortex to increase secretion of cortisol. Cortisol feeds back to both the anterior pituitary to inhibit secretion of corticotropin and to the ventral hypothalamus to inhibit secretion of corticotropin-releasing hormone. The cortisol system is subject to far more dynamic changes than the thyroid system, and all hormones of the cortisol series exhibit a circadian rhythm. Click the pituitary gland to continue. Let's look now at the release of prolactin. Prolactin differs from other anterior pituitary hormones in these important ways. Its primary ventral hypothalamic drive is inhibitory. It does not stimulate release of another hormone from a target gland. Prolactin is secreted in small amounts in both males and females. The amount in adult females is slightly higher than the amounts in males and children because estrogen modulates its secretion. Estrogen increases prolactin secretion, but blocks the effects of prolactin on milk production. For example, the high levels of estrogen during pregnancy cause large increases in circulating prolactin. Prolactin, estrogen, and other hormones promote growth of the breasts, but the high levels of estrogen inhibit milk production. Milk production begins after childbirth when estrogen levels drop due to the removal of the placenta. Click the pituitary gland to see a summary diagram. In summary, endocrine control of the hypothalamic pituitary axis can be exerted by negative feedback from a target hormone to a hormone of its own series, modulation by a target hormone of one series to hypothalamic pituitary hormones of another series.
В общем-то, здесь с 91 по...
The hypothalamus is the highest level integrating center for the autonomic nervous system and the coordinating center for neuroendocrine interactions. Fibers from many parts of the brain influence the endocrine system via hypothalamic neurons. The cerebral cortex is widely connected, both directly and indirectly, to the hypothalamus, parts of the limbic system, thalamus, basal nuclei, reticular formation of the brainstem, and the retina projected of the hypothalamus. Strong emotions like fear, body housekeeping signals like ingestion of food, harmful stimuli that produce pain, trauma, or infection, environmental changes like extreme cold, and light signals from the retina can influence the endocrine system through these circuits. Click the hypothalamus to see a neuroendocrine interaction. Neuroendocrine reflexes like the milk ejection reflex or milk letdown are mediated in the hypothalamus. Suckling induces release of oxytocin that causes the myoepithelial cells of the mammary glands to contract and release milk. The sound of a baby crying can cause a similar letdown of milk, and anxiety and worry can inhibit the milk ejection reflex. Click the hypothalamus again to observe responses of chemically sensitive neurons. Hypothalamic neurons, including the neurosecretory cells that produce vasopressin, behave like osmoreceptors. They detect osmotic changes in body fluids. For example, an increase in the osmolarity of body fluids due to fluid loss, excessive sweating, or diarrhea excites osmoreceptors and stimulates both synthesis and release of vasopressin. Vasopressin acts on the kidneys to promote water reabsorption in an effort to restore normal osmolarity. Click the hypothalamus again to observe circadian rhythm. Neurons of the hypothalamus are pacemakers that generate circadian patterns of hormonal release by the hypothalamic pituitary axis. Circadian rhythms are approximately 24 hours long. The timing of the rhythm is synchronized to the 24-hour Earth day by external signals. We have seen in Topic 2 that cortisol and the hypothalamic pituitary hormones in its series exhibit a circadian rhythm that is synchronized by light. To review what you have already learned about thyroid hormone, And to expand your understanding of it, click this image. One way that scientists learn about the endocrine system is to observe the symptoms of patients who secrete too much or too little of a particular hormone. Diseases associated with the thyroid gland are common. On this page, we will study the effects of hypo and hypersecretion of thyroid hormone. Recall the metabolic functions associated with thyroid hormone and use that knowledge to sort the following symptoms. If the symptom is associated with too little TH, drag it to the left side of the page. If the symptom is associated with too much TH, drag it to the right side of the page. Here's a summary of what we've covered. Hypothalamic neurons produce hormones. Some hypothalamic hormones enter the systemic circulation. To access cross-references for this topic in your Benjamin Cummings textbook, click here. To test your knowledge, click the quiz button.
Опять снова меню найдите. Еще дальше.
Меню, как
Еще дальше.
Давай все возвращаем.
Нет, да.
Нет, что там в прошлый раз не?
Нет, в прошлый раз тоже по одному возвращался.